Hey everyone, welcome back to the channel. Today we're going to install Argo Rollouts on Kubernetes using a proper GitOps workflow with Argo CD and Kustomize. By the end of this video, you'll have a fully functional Argo Rollouts setup with a beautiful dashboard complete with single sign-on. We'll also cover the two most common issues you might run into and exactly how to fix them. So let's dive in. Before we install anything, let's quickly talk about what Argo Rollouts actually is and why you'd want to use it. Argo Rollouts is a Kubernetes controller that brings advanced deployment strategies to your cluster. Now you might be thinking, don't we already have Kubernetes deployments? Well, yes, but standard deployments are pretty basic. With vanilla Kubernetes deployments, you get simple rolling updates with fixed max surge and max unavailable settings. There's no built-in traffic shaping, no automated metric-based decisions, and no smart rollback capabilities. That's where Argo Rollouts comes in. It fills this gap by enabling safe, observable, and automated rollouts. Let me show you what makes Argo Rollouts special. First up, Blue-Green deployments. Think of Blue-Green deployment as having two identical production environments running side by side. You have the active environment, which we call Blue, handling 100% of your live user traffic. Then you have the preview environment, Green, which runs your new version but is only accessible to you for testing. This strategy lets you fully validate the new version in a real production setting without affecting any users. Once you're confident everything works, you just flip the switch. We call this a cutover, and all traffic instantly moves to the green environment. The beauty here? Absolutely zero downtime. And if something goes wrong, just flip back. Instant rollback. Now let's talk about Canary deployments. This is like testing the waters before jumping in. Instead of switching everyone to the new version at once, you gradually roll it out. Let's say you start with 10% of your users trying the new Canary version, while 90% stay on the stable version. Here's where it gets really cool. Argo Rollouts actively watches the Canary version. Is it generating errors? Is it slow? Is the latency spiking? If the metrics look good, Argo Rollouts gradually increases traffic. 20%, then 50%, then 100%. But if it detects issues, automatic rollback. No pager duty at 3 a.m. required. This is perfect for catching bugs that only show up with real user traffic, and it dramatically reduces your blast radius if something goes wrong. Let me quickly highlight the other killer features of Argo Rollouts. First, traffic management integrations. Argo Rollouts work seamlessly with popular ingress controllers like Traefik, Nginx, Istio, and AWS ALB. This gives you percentage-based traffic splitting and header-based routing. Second, automated analysis and health checks. Instead of just checking if pods are ready, Argo Rollouts can query Prometheus, Datadog, New Relic, CloudWatch, or even custom webhooks. You can set thresholds like error rate must be less than 1% or P95 latency must be under 500 milliseconds. Third, manual approvals and pauses. You can pause rollouts at specific steps and require manual approval before proceeding. Perfect for production change control. And finally, first-class observability. You get rich CLI tools. We'll use Kube Control Argo Rollouts, plus visualization right in the Argo CD UI. All right, let's get into the installation. There are two main ways to install Argo Rollouts. Method 1, direct Helm installation. This is the fastest way but doesn't follow GitOps principles. Good for testing and development. Method 2, Kustomize plus Helm with Argo CD. This is the GitOps way. Everything is version controlled in Git, declarative, and automatically synced. This is what we'll be using today. Why GitOps? Because every change is tracked in Git, it's fully auditable, and Argo CD keeps your cluster automatically in sync with your repository. No more, it works on my machine problems. If you're just testing things out locally, here's the quick Helm install. First, add the Argo Helm repository, install it with this command, then create a custom values.yaml file. Here's what mine looks like. In the controller section, we're setting resource requests. That's 100 millicores CPU and 64 meg of memory. Think of requests like reserved parking for your pods. Then we set limits, 400 millicores and 128 meg. Limits are like speed limits. Your pod can't exceed these. We also enable the dashboard, which gives us that beautiful web UI. Install it with this command. Done. But let's move on to the proper GitOps way. For the GitOps approach, we need to set up our directory structure. Let me show you what we're working with. We have an Argo Rollouts directory with two main parts. First, the Argo Rollouts app.yaml file. This is the Argo CD application manifest. Think of it as the blueprint that tells Argo CD what to install and where. Second, the Argo Rollouts app directory, which contains customization.yaml, orchestrates everything. Custom values.yaml, our Helm customizations, ingressroute.yaml, exposes the dashboard one important note. Argo Rollouts is a cluster-level controller. Unlike your application deployments, you only install it once per cluster, not per environment. Let's break down the Argo CD application manifest. This is the control center of our installation. At the top, we have metadata with a finalizer. This ensures Argo CD properly cleans up resources when you delete the application. Without this, you'd have orphaned resources hanging around your cluster. Next, we have ignore differences. This is important. It tells Argo CD to ignore certain CRD fields that Kubernetes automatically mutates. We'll come back to this in the troubleshooting section. In the project field, specify your Argo CD project. I'm using ServiceFoundry, but you might use default or whatever project you've set up. The source section tells Argo CD where to find your manifests. The repo URL. Update this to your Git repository. Target revision, I'm using head, which means the default branch, path, the directory containing the customization.yaml file. The destination section says where to deploy Sauchamia server Kubernetes. Default.svc means the same cluster where Argo CD is running. Namespace, we're deploying to the Argo Rollouts namespace finally. Sync policy, this is where the GitOps magic happens. Prune, true means delete resources removed from Git. Self-heal, true means revert manual changes to match Git. Create namespace, true, auto creates the namespace. Retry settings handle transient failures with exponential backoff. Now let's look at the customization.yaml file. This is the heart of our installation. Kustomize is a Kubernetes native configuration tool. It lets us combine multiple resources, apply transformations, and integrate Helm charts, all in a clean, declarative way. First line, namespace. This sets Argo Rollouts as the default namespace for everything. Resources section, we're including the ingressroute.yaml file, which exposes our dashboard. And here's the cool part, the Helm charts section. We tell Kustomize to pull the Argo Rollouts chart version 2.40.5 from the Argo Helm repo, apply our custom values file. Why this approach? We get the best of both worlds, Helm's powerful templating plus Kustomize's simplicity. The chart version is pinned in Git for reproducibility, and it's easy to add extra resources alongside the Helm chart. The ingress route is optional. If you're not using Trafic or if you prefer Kube Control Port Forward for local access, you can skip this. But if you want to expose your dashboard to the web with HTTPS and single sign-on, here's what you need. This file actually contains 3 Trafic resources. First, the ingress route itself. It accepts traffic on both HTTP and HTTPS entry points. We define 3 routes. Route 1 handles /rollouts, the dashboard UI. It's protected by our forward auth middleware for SSO. Route 2 handles /API calls. This is how the front end talks to the back end. Also protected by SSO. Route 3 catches requests to just slash and redirects them to /rollouts for convenience. Important, replace Argo Rollouts .servicefoundry.org with your actual domain. The second resource is a redirect middleware using regex to append /rollouts to the root path. The third resource is the forward auth middleware. This integrates with OAuth 2 proxy for single sign-on. Update the address if you're using a different SSO solution, or remove this middleware entirely if you don't need authentication, though I don't recommend that for production. If you don't want to mess with ingress, just use the port forward command. Then visit localhost :3100/rollouts in your browser. All right, time to deploy this thing. The process is beautifully simple. Step 1. Commit everything to Git. Commit all your files to the repository. Step 2. Create the Argo CD application. Apply the application manifest with kube control. This tells Argo CD, hey, watch this Git repo and keep my cluster in sync with it. Step 3, watch the magic happen. Behind the scenes, Argo CD is 1, pulling your Git repository. 2, running Kustomize to render the Helm chart. 3, creating the Argo Rollouts namespace. 4, installing the controller dashboard and CRDs. 5, applying your ingress route. In the Argo CD UI, you can see the application appear in your applications list. Click on it, and you'll see all the resources getting deployed. Look for these success indicators: sync status, synced; health status, healthy, all pods running. Perfect. Now let's access the dashboard. Go to your domain, in my case, Argo Rollouts .servicefoundry.org/rollouts, and loading screen that never finishes. Don't worry, this is totally normal. Let's fix it. If you're seeing an infinite loading spinner, you just ran into the first common issue. Let me explain why this happens. This is actually a known quirk in the Argo Rollouts dashboard. The dashboard expects to find at least one rollout resource in the cluster. If there are 0 rollouts, the API returns an empty list, but the front end never finishes loading. It's like walking into a library and asking for books when the library is completely empty. The librarian doesn't know how to respond. The fix? Give it a dummy rollout. Let me show you. Create a file called rolloutsdemo.yaml. This is a minimal rollout that uses a canary strategy with 4 steps: 20% traffic, pause, 40%, 60%, then 80%, and finally 100%. It uses the official Argo demo image, just a simple web app that displays a colored square. Apply it with the apply command. Now refresh your dashboard. The loading spinner should stop and you'll see your rollouts demo appear. Success. You can delete this demo later once you have real rollouts. The second common issue is seeing your application as out of sync, even though it's healthy. Let me show you what's happening. Your application shows health, healthy, sync, status, out of sync. The out of sync resources are the CRDs themselves: rollouts.argoproj.io, analysis runs, analysis templates, and so on. Here's what's going on. When you apply a CRD to Kubernetes, the API server automatically modifies it. It adds status fields for cluster state, injects metadata annotations, reorders the OpenAPI schema, and applies conversion defaults. These changes don't exist in your Git repository, so Argo CD sees them as drift. This is completely normal. Kubernetes needs to track state. The problem is compounded when using Kustomize. Here's the cycle. 1. Kustomize renders the Helm chart to raw YAML. 2. Argo CD applies the raw CRD manifests. 3. Kubernetes mutates the CRDs. 4. Argo CD compares Git, no mutations, versus cluster with mutations. 5. Result out of sync. Kustomize doesn't normalize these server-side changes the way Helm does, so the drift is the fix. Tell Argo CD which fields to ignore. Add ignore differences to your application manifest under the spec section. We tell it to ignore .spec, changes to the CRD specification like schema reordering, .status, status fields for cluster state, .metadata, .annotations, tracking metadata. What this says is, for any custom resource definition, ignore differences in these specific fields. Apply the updated manifest with the apply command. Argo CD will reevaluate and boom, synced. Check your application and the CRDs should no longer be marked as out of sync. Now that everything is healthy, let's see what the final user experience looks like in a secured production environment. Because we set up that ingress route with single sign-on earlier, we're not just exposing our dashboard to the open internet, we're securing it. Navigate to your domain, argorollouts.servicefoundry.org. Notice that you don't go straight to the dashboard. You get redirected immediately to the login page. This is our OAuth 2 proxy at work. I'll sign in with my authorized credentials, and success. We are redirected back to the Argo Rollouts dashboard. This is exactly how you want to set this up for production. Only authorized team members can access the controls, ensuring your deployment pipeline remains secure. And that's it. We've successfully installed Argo Rollouts using a proper GitOps workflow. Let's recap what we covered, what Argo Rollouts is and why it's awesome, Blue-Green and Canary deployment strategies, 2 installation methods, Quick Helm and proper GitOps, the full GitOps setup with Argo CD and Kustomize, how to expose the dashboard with an ingress route, fixing the infinite loading dashboard issue, fixing the CRD out of sync issue. In the next video, we'll dive into actually using Argo Rollouts. We'll create real rollouts, perform Canary deployments, set up automated analysis, and see rollbacks in action. If you found this helpful, smash that like button and subscribe for more Kubernetes and GitOps content. Drop a comment if you have questions or run into any issues. Thanks for watching, and I'll see you in the next one.